Good morning, learners. Good morning, teachers. My name is Mohapi, and I am working here at Muteo District as the subject advisor for mathematics. Let me take this opportunity to welcome everyone viewing this program, and I hope at the end of the day, you will be inspired and motivated, more especially you learners, considering the fact that this coming Friday, we will be writing mathematics paper 1. So one of the topics that will be examined in this coming mathematics paper 1 will be number patterns. As a result, in today's lessons, for the next 2 hours, we'll only be focusing on the number patterns. I hope that one is clear. And because we are doing we are doing the revision now, we are preparing ourselves for the September examination, which will be written this coming Friday. There will be lots and lots of activities that I'm going to engage you in. Learners, I hope you got your pens are ready. I hope your books are ready, because I'm going to give you lots and lots of activities. So your task will be to respond to those activities, and then at the same time, I will also work out the solution. Then you can compare your workout against mine. I hope you'll find this session inspiring and fruitful, and you will benefit a lot. Teachers, please always assist your learners. Be there for your learners. Support them, because we really want to see them passing mathematics at the end of the year. Thank you. Without any waste of time, let me start with the topic for today. Number patterns. The topic for today is number patterns. And we know number patterns can take different forms. So I'm going to take you through this first exercise. And then the next exercise, I think you learners must be able to do it. We've got different types of number patterns. The first one is the linear number pattern. The question states, consider the following linear number pattern. If you look at, once we talk of a linear number pattern, then you as a learner, you must know exactly what a linear number pattern is. That is very much crucial. So in this case, once we talk of a linear number pattern, we know that a linear number pattern is a pattern in which the first difference is common. A linear number pattern is a pattern in which the first difference is common. Let's check the example that is projected at the screen. 7, 12, 17. And it is clearly stated that this is a linear number pattern. It is clearly stated that this pattern is a linear one. So we know for sure that once it is a linear number pattern, then the first difference must be common. Let's check. 1.1. We've got 2, we've got 7, we've got 12, and you also have got 17. It's a number pattern. Let's check the first difference. Difference between the first two terms. 7 minus 2 gives us 5. Let's check the difference between these successive terms. 12 minus 7 gives us 5. Third difference, 17 minus 12 gives us 5. This shows that this is a linear number pattern because the first difference is common. We only determine the difference here. 7 minus 12. The answer you get when you subtract is called the difference. So 7 minus 12 gives us 5. 12 minus 7, 5. 17 minus 12, 5. So in all these instances, the difference between successive terms is 5. So once the first difference is common, that pattern is called linear number pattern. So it means to determine the next term, we just have to keep on adding the common difference. Thank you. Check. We agree that the first difference is 5. It's 2. In 2 you add 2 plus 5 will give you 7. 7 plus 5 will give you 12. 12 plus 5 will give you 17. Then you continue the sequence. Then you continue the pattern. 17 plus 5, I think 17 plus 5 will then give you 22. 17 plus 5 will then give you 22. Again, 22 plus 5 will then give you 27. What does that mean? If we answer the question states Write the first question, 1.1. Write down the next 3 terms of the sequence. Write down the next 3 terms of the sequence. So how do we do that? We have realized that the common difference is 1. So we keep on adding the common difference. The common difference is 5 in this case. So 17 plus 5 gives us 22. 22 plus 5 gives us 27. 27 plus 5 will then give us 32. So the next 3 terms of the sequence will then be 12, will then be 22, 27, 32. I hope you got that one clear. The first question states, write down the next 3 terms of the sequence. Because it is a linear number pattern, the first difference is common. So in this case, the first difference is 5. So to determine the next term, you just add 5. 17 plus 5 gives us 22. 22 plus 5 gives us 27. 27 plus 5 gives us 32. So when answering 1.1, write down the next 3 terms of the sequence. The next 3 terms of the sequence will be 22, 27, and 32. 1.1, I think we're happy. I think you're happy. Check 1.2. 1.2 states, determine the nth term of the sequence. Remember, this is a linear number pattern. A linear number pattern. So the linear number pattern is given by Tn equals to An plus B. The linear number pattern. Once you talk of a linear number pattern, we know that it's An plus B plus B. What does this A represent? In this case, A represent common difference. A represent common difference. So in this case, our common difference was 5. This means that A is equals to 5. So if A is equals to 5, we then substitute the value of A in this general term formula. Therefore, the nth term will then be equals to 5n plus B. 5n plus B. Meaning that if the question states determine the nth term of the sequence, all we have to do is to determine the value of A and the value of B. The question states determine the nth term of the sequence. Our task is to determine the value of A and the value of B. So, fortunately enough, we already have the value of A because A is the common difference. A is the first difference. So, first common difference is 5. Substitute A by 5. 5n plus 6. Plus B. Plus B. So, the question is, how do we determine the value of B? I hope you still remember. How do we determine the value of B? Let's check. To determine the value of B, we use all these terms that are already given there. You can say the first term is 2, the second term is 7, the third term is 12, the fourth term is 17, anyone. But I always advise us to use the term number 1 because substituting with 1 becomes so easy. If you can check term number 1, our first term is 5. Our first term is 2. Sorry for that, slovenly work. Our first term is 2 because the first term is 2. Second term is 7, third term is 12, fourth term is 17. So our first term is 2. So we say we substitute n by 1. We substitute n by 1. Remember we wrote Tn, the nth term. So T1 is 2, meaning that we substitute n by 1. Here is Tn, term number 1 is 2. 5, substitute n by 1 plus B. Now we determine the value of B. We've got 2. 5 multiplied by 1 gives us 5 plus B. Transpose 5 to the left, you'll be left with B on the right hand side. On the left hand side, then it will be 2 minus 5, which will give you negative 3. 2 minus 5 will give you negative 3. There is our negative 3. Then we conclude, therefore, the nth term will then be equals to An plus B. Our A is 5. It's going to be 5n minus 3, because the value of b here is -3. Our value of b here is -3. So what do? We substitute this -3 in this formula. Therefore, we've got Tn is equal to 5n minus 3. I hope it's clear. Determine, the question states, if you remember the question properly, the question states 1.2, determine the nth term of the sequence. Determine the nth term of the sequence. So the nth term of the sequence is given by n is equal to an plus 5 plus b. And this a represents the first common difference. So the first difference, which is common in this case, was 5. As a result, a is equal to 5. You substitute a by 5, you've got Tn is equal to 5n plus b. So we need to determine the value of b. Check term number 1. Our first term there is given as 2. From the sequence, you can check. First term is 2. So our first term, if our first term is 2, what do? Say T1 is equal to 2. It means we're going to substitute the value of n by 1. 2, 5 into 1 plus b. 5 multiplied 1 gives us 5. Then we transpose 5 to the left. Got 2 minus 5, which gives you -3. On the right hand side, you're only left with b, meaning that the value of b is equal to -3. Therefore, the nth term will then be equal to 5n minus 3. I hope you're happy with that solution. I hope you are happy with that solution. That is our nth term. Let's look at the next question then, 1.3. Because 1.1 and 1.2 have been answered, and I hope we are still following. Let's answer 1.3. 1.3 states, check one, determine, calculate 199th term. Calculate 199th term. Thank you. Remember, when answering 1.3, our general term, our Tn is equals to 5n minus 3. What does that mean? If we determine 199th term, what it means is that we need to substitute the value of n by 199, because n in this case, they indicates the position of a term in a sequence. N indicates the position of a term in a sequence. So we've got, now in this case, the position is given. It's term number 199. So we want the value of that term. Hence the question states, calculate the 199th term of the sequence. T199 is equals to, you substitute n by 199. 5 into 199 minus 3. Then we carry on, we multiply 199 by 5. You take out the calculators. 5 multiplied by 199, I think 5 multiplied by 199 will give you 995. It gives 995 minus 3. Therefore, term number 199 will then be equal to 995 minus 3, it will give you 992. And this answers 1.3. Because in 1.3, the question states calculate 199th term of the pattern. And the word hence, maybe I should explain the word hence. The word hence indicates that you use the above solution to solve this one. In the 1.2, determine the nth term of the sequence. The nth term of the sequence was Tn is equal to 5n minus 3. The word hence means from the above solution, solve this one. Hence, we used the solution that we got in 1.2 to solve 1.3. Thank you. I hope we're still going on well. We are happy with 1.3. Let's check 1.4. Let's check 1.4 then. Let's check 1.4. Therefore, thank you very much. There we are. 1.4. Which term of the pattern is equal to 497? Which term of the pattern is equal to 497? Remember, we've got our nth term, 1.4. from 1.2, our nth term is equals to 5n minus 3. That is our nth term. So the question is, which term is equal to 497? Remember what I said earlier. I said n indicates the position of a term in a sequence. N indicates the position of a term in a sequence. Check 1.3. The position of that term is 199. The position of the term is 199. That's why we substitute n by 199. So 1.4, which term of the pattern is equal to 497? We need to determine the value of n. We've got the nth term. The nth term is 497. We don't know the position of 497. It's the nth term. So this is how we solve the problem. The nth term will then be 497 is equals to 5n minus 3. 5n minus 3. So we need to solve for n. For us to solve for n, here is 5n. You've got minus 3 here. You transpose it to the left. Then you've got 497 plus 3, which will give you 500. 5n is equals to 500. Now we just have to divide by 5 both sides to determine the value of n. So if you divide by 5 this one, you'll be left with n. You divide by 5, you'll be left with 100. So n is equals to 100. What does that tell us? It therefore means term. It therefore means term 100 is the one that is equals to 497. 497. I hope you enjoyed this one. It is a linear number pattern, and it isn't that difficult. Linear number pattern is very much easy to work with. Remember, we work with different types of sequences here. So most common one, linear number pattern. And we at grade 12, we know very well that the linear number pattern is also referred to as arithmetic pattern, arithmetic sequence. Thank you. The solution to number 1 is done. Like I indicated, you're going to be engaged in lots and lots of activities. So strictly, I'm going to give you 5 minutes to find the solution for the next one. I'm going to give you 5 minutes to find the solution for the next one, and then thereafter, you can then check your work against mine. Remember, time is very much important. Let's look at number 2. Let's solve number 2 together. Thank you. I think number 2 is nicely projected at your screens. May I just read it for you? Consider the following linear pattern. Again, you are still being given the linear number pattern. The first term is -6, -10, -14, -18, and so forth. So the first question states, write down the next 3 terms of the sequence. 2.2, determine the nth term of the sequence. 2.3, hence calculate 600th term of the pattern. And then the 2.4, which is the last one on number 2, which term of the pattern is equals to minus 442. Strictly after 5 minutes, you must be done. Work it out then. Then you'll check your work against mine. Welcome, 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 welcome. Thank you very much. Thank you very much. Let's carry on with the solution for number 2, 2.1. Let's check at 2.1. 2.1, the first question says, write down the next 3 terms of the sequence. Write down the next three terms of the sequence. 2.1. Remember, the first term is -6, -10, -14, -18. So to write down the next 3 terms of sequence, you just have to keep on subtracting -4. Common difference here is -4. Check. The first difference is a linear number pattern. It is given that this is a linear number pattern. So if it is a linear number pattern, the first difference is common. Check. -10 subtract -6. Then you'll end up with -4. -14 subtract -10. You still end up with -4. Negative 18, subtract negative 14. You still end up with negative 4. So the common difference is, the first difference, which is common, is negative 4. So you just have to keep on subtracting negative 4. So it's negative 18. If you subtract 4, you've got negative 22. Subtract 4, negative 26. Subtract 4, negative 30. So those are the next three terms of the sequence. Negative 22, negative 26, negative 30. I hope you are all okay with that one. And I hope you all manage to get it right. So the next three terms of this sequence, minus 22, minus 26, minus 26, and negative 30. The next question, 2.2. Determine the nth term of the sequence. 2.2. Determine the nth term of the sequence. If you remember very well, I said that the nth term is given by the formula an plus b. So you need to know, what does this a represent? A represents the common difference. So from this equation, the common difference here is negative 4. Negative 4. So all we have to do, we substitute the value of a by negative 4. We substitute the value of a by negative 4. Therefore, the nth term will then be equals to minus 4n plus b. So the question is now, how do we determine the value of b? How do we now determine the value of b? Check the first term. The sequence that is given, negative 6 is our first term. Negative 6 is our first term. It means term number 1 is equals to negative 6. What does that mean? Let's, for n, we substitute 1. So T1 here, n we substitute is minus 4, n you substitute 1 plus b. But T1 is T1. Instead of 1, you put in negative 6. Instead of 1, you put in negative 6. Thank you. Now we can work it out nicely. Negative 6. 4 multiply, negative 4 multiply 1, negative 4 plus b. Let's determine the value of b. Therefore, b is equals to minus 6 plus 4 will then give you negative 2. Now you can write down the nth term of the sequence. Therefore, it means the nth term of this sequence is an plus b. A is negative 4. Then you've got minus 4n. Our b here, our b is negative 2. We substitute b by negative 2. Here is b. Then we've got minus 2. That is our nth term of the sequence. Our nth term is equal to minus 4n minus 2. I hope you also managed to get it right. I hope you also managed to get it right. Look at 2.3. 2.3. 2.3 states, calculate the 600th term of the sequence, term number 600. Remember, 2.3. Our nth term is minus 4n minus 2. Minus 4n minus 2. So all we have to do is to substitute n by 600. T 600 minus 4, substitute n by 600 minus 2. Let's multiply throughout the aid of our calculators. I think if you multiply 4 by 600, you'll end up with minus 2,400 minus 2. Therefore, term number 600 is equals to minus 2,402. That is how to answer 2.3. That is how to answer, to respond to 2.3. The last question. Which term of the pattern is equals to minus 442? Which term of the pattern is equals to minus 442? Now, this is how we work it out. This is how we work it out. Thank you. This one, 2.4. 2.4. Remember, our nth term is equals to minus 4n minus 2. So which term is equals to minus 442? That is our nth term because it occupies an unknown position in the sequence. We do not know its position. We need to find its position. So for us to determine the position of that term, we need to determine the value of A. Thank you. Let's carry on. Minus 442 is equals to minus 4n minus 2. Let's group the like terms and see what happens. It's minus 4n here. Minus 4n transposed to the left. Minus 4n transposed to the left. It becomes positive 4n. We are only left with minus 2 here. Then it means minus 442. Minus 442, you transpose it to the right. Then it becomes positive 442. So 442 minus 2 will give you 440. Will give you 440. Now we just have to divide by 4 both sides to determine the value of n. 4n divided by n by 4, 4n divided by 4 is n. 440 divided by 4 is 110. Because what you do on the left, you also do on the right. If you divide by 4 here, you also have to divide by 4 on the right-hand side. If you divide the left-hand side by 4, you must also divide the right-hand side by 4. So n is equal to 110. What does that tell us? It therefore means term number 110 is equals to negative 442. Thank you very much. I hope you enjoyed this one, and I hope you got it right. Those who did not get it right, I hope they've managed to see or to identify their mistakes. Because it is important when you work out the solution, you must be able to know exactly where you went wrong. I hope you are happy with solution to number 2. We are busy with number patterns. So I think for now we have been focusing mainly on the linear number pattern. We have been focusing mainly on the linear number pattern. And in the linear number pattern, the first difference is common. That is very much important. Linear number pattern, the first difference is common. Or you can just simply say in an arithmetic sequence, it has got a common difference, which we denote by the letter D. Thank you very much. Let's carry on with some more exercises. But right now, I want to change to the quadratic number pattern. This is very much important. Quadratic number pattern. Let's talk a bit about quadratic number pattern. Quadratic number pattern. I think you must be familiar with this topic by now. Quadratic number pattern. And what is important about quadratic number pattern is that number 1, second difference is common. It's very much important to know that. When you're dealing with quadratic number pattern, the second difference is common. Remember, in the linear number pattern, we said the first difference is common. So, in a quadratic number pattern, the second difference is common. And let me give you the general form of a quadratic number pattern. Quadratic number pattern is given by Tn an squared plus Bn plus C. So, if the question requires you to determine the L term of the quadratic number pattern, it means you must first determine the value of A, and then the value of B, and then the value of C. A quadratic number pattern is a pattern in which the second difference is common. The second difference is common. So, because you are just now busy preparing for the examination, the question is, now if we are given a sequence, we have a sequence like this one, how do we determine the value of A? Remember, we always say to determine the value of A, 2A is equals to second, that is key. 2A is equals to second difference. That is how we determine the value of A. To determine the value of A, 2A is equals to second difference. Let's check the value of B. Remember, to determine the value of B, we normally say 3A plus B will be equals to the first term of the first difference, T1 of first difference, the first term of the first difference. That is how we determine. Remember, from this step, we have already determined the value of A. So it's easy for us to substitute A here, and then we can determine the value of B. because the first term of the first difference can also simply determined by subtracting or by determining the difference between the given terms. Thank you. Then the last aspect, how do we determine the value of C? For us to determine the value of C, remember, is A plus B plus C must be equal to the first term of the pattern. The first term of the quadratic number pattern. The first term of quadratic pattern. Here, to determine the value of B, we said 3A plus B, we equated it to the first difference, the first term of the first difference. Here we say A plus B plus C equals to the first term of the quadratic number pattern. That's how we go about in solving a quadratic number pattern. What is key with regard to quadratic number pattern is that the second difference is common. A quadratic number pattern is a pattern in which the second difference is common. Check this one. Let's do this one together. Check number 3. I think it's clearly projected, it clearly appears in your screens, and it reads as follows. Consider the following quadratic number pattern. Consider the following quadratic. It is given that that is a quadratic number pattern. The first question, write down the next 3 terms of the sequence. Let's write it down. 3.1. Remember, we've got a quadratic number pattern. We've got 6, 13, 22, 33. Let's determine the first difference. 13 minus 6. That's how we go about. 13 minus 6 will give you 7. 22 minus 13. 22 minus 13, I think it will give you 9. 33 minus 12. 33 minus 12 gives you 11. Let me repeat. This is the pattern that is given to us, a quadratic number pattern. Consider the following quadratic number pattern. It is a quadratic number pattern. 6, 13, 22, 33. So what we're doing, because it is given as a quadratic number pattern, we know that the second difference must be common. Once it's a quadratic number pattern, we know that the second difference must be common. And from here you can tell that the second difference, 9 minus 7 is going to give you 2. 9 minus 11 is also going to give you 2. So the second difference is already common as 2. But in this instance, the question says, write down the next 3 terms of the sequence. So we've the first difference. And from the first difference, you can tell that the first difference is a linear number pattern. So we just have to keep on adding 2. It's 7 plus 2 gives you 9. Plus 2 will give you 11. If you add another 2 again, I think you'll get 13. You add another 2 again, you'll get 15. Add another 2 again, you'll get 17, and so forth. Because this is a quadratic number pattern. If it is a quadratic number pattern, the second difference is common, is 2. 7 plus 2, 9. Plus 2, 11. Plus 2, 13. Plus 2, 15. Plus 2, 17, up to infinity. So let's determine, the question states, let me show the question clearly. The question states, write down the next 3 terms of the sequence. Check. 6 plus 7 gives us 13. 13 plus 9 gives us 22. 22 plus 11 gives us 33. Now the question is, what? 33. 33 plus 13. We need to say 33 plus 13, which will then give us 46. That will be the first term. 46. Let's carry on. 46 plus 15. We just have to keep on adding. It will give you 61. This 61 plus 17. I think 61 plus 17 will then give you 78. It means if the question says determine the next 3 terms of the sequence. So the next 3 terms of the sequence are 46, 61, and 78. Those are the next 3 terms of the sequence. The question states determine the next 3 terms of the sequence. So the next 3 terms of the sequence are 46, 61, and 78. 8. Let's look at 3.2. Determine the nth term of the sequence. Determine the nth term of the sequence. It's easy because I've already outlined the procedure for you. To determine the nth term, remember, the sequence is the quadratic number pattern. So the sequence is given by quadratic number pattern. We said the quadratic number pattern is 3.2. It's Tn is equals to an squared plus bn plus c. So how do we determine the value of a? Remember we said a is equals to the second difference. So you say 2a. Remember our second difference in this case, it was 2. So 2a is equals to 2, a is equals to 1. Determine the nth term of the sequence. To determine the nth term of the sequence, this is how we do it. 2a is equals to second difference, and our second difference is 2. Therefore, a is equals to 1. Now let's determine the value of b. Remember, to determine the value of b, you say 3a plus b must be equals to the first term of the first difference. T1 of the first difference. Let me show you the difference. This is the second difference. It's clear. Second difference is 2. The first term of the first difference is 7. The first term of the first difference is 7. And the first term of the pattern is 6. So to determine the value of b, we say 3a plus b is equal to the first term of the first difference, meaning that 3a plus b will be equal to 7. Now let's work it out then. Let's work it out. 3a plus b is equal to 7. But remember, we already determined the value of a. Our a is 1 here. Ne? So we say we substitute this a is equal to 1 into this equation. 3 multiplied by 1 plus b will then be equal to 7. Now 3 multiplied by 1 gives us 3 plus b is equal to 7. Then you transpose 3 to the right. You'll only be left with b on the left. So 7 minus 3 give you 4. We've got the value of a, we've got the value of b. The general term, Tn is equal to an squared plus bn plus c. Now we've got the value of a. We're happy we've got the value of a. We've got the value of b as 4. It's correct. Now we only need to determine the value of c. We still have to determine the value of c. This is how we determine the value of c. Remember, we said a plus b plus c is equal to the first term of the pattern. So the first term of the pattern is equals to 6. Now let's substitute. Remember, a is 1. A is 1 plus b is 4 plus c. The answer must be 6. Now we have to solve for c. 1 plus 4 gives us 5. In this 5, transpose it to the right. You'll be left with 6 minus 5, which will give you 1. Therefore, what does that mean? It means the nth term of the pattern is an squared. Remember, it's an squared. If it can, it's an squared. So we've got the value of a. Our a here is 1. So we've got n squared. B is 4 plus bn. B is 4. You substitute b by 4, then you've got 4n. C is 1. Then you've got plus 1. So the nth term of the sequence is, our nth term of the sequence is n squared plus 4n plus 1. N squared plus 4n plus 1. I know you're getting tired. Let's finish off this exercise, and then immediately after this exercise, I'll give you a 10 minutes break so that we can then continue after that break. Now we have answered 3.1 and 3.2. 3.1 and 3.2. Check 3.3. 3.3 states, hence calculate the 100th term of the sequence. What I like is that 3.3. Hence, the solution that you've already got up, use it here. So the word hence, use the solution you got in 3.2 to solve 3.3. And in 3.2, we have the nth term as n squared plus 4n plus 1. So the question states, determine the 100th term of the sequence, term number 100. So it means you substitute n by 100. 100 by n, substitute n by 100 plus 1. Let's simplify. 100, if you square it, it will give you 10,000. Plus 100 multiplied by 4 will give you 400 plus 1. So you add all the three terms together, you'll then get 10,401. I think this is 3.3 when we want to determine the term number 100. Term number 100 of the sequence will be equals to 10,401. Let's answer the last question then. The last question, 3.4. Which term of the pattern is equals to 118? Which term of the pattern is equals to 118? Let's answer 3.4 then. 3.4. Remember our nth term? Our nth term is Tn is equals to n squared plus 4n plus 1. Plus 1. So which term is equals to 118? 118 will be our nth term because we do not know its position. We don't know the position of 118. So all we have to do, we need to substitute Tn here by 118, which is equals to n squared plus 4n plus 1. Remember what I said earlier. N indicates the position of a term in a sequence. N indicates the position of a term in a sequence. So if we can determine the value of n, we will know the exact position of 118. Because at the moment, we don't know. I personally don't know. I need to work it out first. Once I've worked it out, I will then know exactly the position occupied by 118 in the term. So this is a quadratic equation. Let's write it in standard form. N squared plus 4n. You need to transpose 118 to the right. Then it will be 1 minus 118. It will be minus 170. Now we need to play around with our factorization. It's a quadratic equation. Let's determine the factors. Remember, if you are unable to determine the factors, you can always use a quadratic formula. But I think the factors here aren't that difficult because they must differ by 4. And I think the factors here should then be 13 and 9. Because 13 multiplied by 9 will definitely give you 117. And the difference between 13 and 9 is 4. So 13 and 9 are the correct factors. Check the middle term is positive. If the middle term is positive, it means the bigger factor will then take the sign of the middle term. I've got plus, this one will be minus. It has to be plus and minus so that they should give us minus 117. Now we solve for n. From quadratic equations, we know n plus 13, n minus 9, therefore it means n plus 13 is equal to 0, or n minus 9 is equal to 0. Now we solve for n. Here n is equals to negative 13. Here n is equals to 9. What does n represent? We ask ourselves that question again. What does n represent? The position of a term in the sequence. So it means n must be a natural number. This term, it is there in the sequence. So what is its position? As a result, this one, n is equals to negative 13, is not applicable. This one we need to cancel it out. It's not applicable. Why? Because n represents the position of a term. So the position must definitely be a natural number. So n, therefore, the correct answer is n is equals to 9. What does that mean? It therefore tells us that term number 9 is the one that is equals to 118. Term number 9 is the one that is equals to 118. Thank you very much. I can give you a break, 10 minutes break, and I believe after 10 minutes, I'll give you an exercise similar to this one, so that you must be able to do it yourself. 10 minutes break, it's almost 5 to 10 right now, and then at 5 past 10, you must be seated with your pens ready, because I'm going to give you an exercise which is similar to this one, and I hope you'll be able to solve it on your own. Thank you very much. Have a break, and then we'll meet up after 10 minutes. Welcome learners. Welcome learners. We're carrying on with the number patterns. Sorry for that. The next exercise that I want you to do for me, check at number 4. Consider the following quadratic pattern. It is given that it is a quadratic pattern. 6, 17, 34, 57. Consider that quadratic pattern and then answer those questions. 4.1, write down the next 2 terms of the pattern. 4.2, determine the nth term of the sequence. 4.3, hence calculate the 50th term of the sequence. And then the last one, 4.4, will then be which term of the pattern is equals to 162. Which term of the pattern is equals to 162. I think I'm going to give you 5 minutes to solve that one. You are from break now. This must be easy for you. In 5 minutes time, you can then check your work against mine. Thank you very much. Carry on with that one. Welcome learners. Check your work against mine. Remember, we also need to practice pace. We need to be able to finish off these problems in a stipulated period of time. We cannot spend lots and lots of time working on this one. Time is very much important. Thank you. Consider the following quadratic pattern. It is given that it's a quadratic number pattern. It's clear, it is stated that this is a number pattern. So the first question states, write down the next two terms. Remember I said 4.1, always advisable. Write down the sequence first. 6, 17, 34, 57. Then the question states, write down the next 2 terms. So first term, write down the next 2 terms of the sequence. It's going to be difficult. But for us to determine the next 2 terms, first remember it is clearly stated it's a quadratic pattern. So let's determine the first difference. 17 minus 6. 17 minus 6 will give you 11. 34 minus 17. 34 minus 17 will give you 17. 57 minus 34. And I think 57 minus 34 will give you 7 minus 4 is 3, 5 minus 3 is 2, 23. If it is stated that it's a quadratic number pattern. So the first difference always represent a linear number pattern. So check the linear number pattern. It's 11. You need to say, for you to get 17, you add 6. Second difference here is 6. 23 minus that one is 6. So it means in the linear number pattern, to determine the next term, you just need to add 6. Let's continue then. 23 plus 6 will then give you 29. 29 plus 6 will then give you 35. So it becomes easy for us to continue the sequence. Check. 6 plus 11, 17. 17 plus 17, 34. 34 plus 23. 34 plus 23 will give you 57. Now we say 57 plus 29. 57 plus 29, let's add them together. 9 and 7 will give you 16. 6, 5 plus 2, 7 plus that one is 8. So it means the next term will be 86. The next term will then be 86. To determine the last term, 86, you add 35. So 6 and 5 will give you 1, carry 1, 8 plus 3, 11 plus the other one is 121. So it means the next 2 terms will then be 86 and 121. Those are the next 2 terms of that quadratic number pattern. 4.1, the question states, write down the next 2 terms of the sequence. So the next 2 terms are 86 and 121. I hope you are happy with that one. And I hope you got it right. Let's check the next one. 4.2. 4.2 states, determine the nth term of the sequence. Determine the nth term of the sequence. 4.2, determine the nth term of the sequence. Remember, from the previous exercise, we are now at 4.2. From the previous 4.1, our common difference is 6. First difference, first term. These are the terms that we are going to use to determine the nth term. Those are the terms that we are going to use the nth term. So the question states 4.2 determine the nth term of the sequence. 4.2, the nth term of the sequence. So remember we said the nth term of a quadratic number pattern is given by Tn is equals to an squared plus Bn plus C. So to determine A, we said 2A is equal to the second difference. Our second difference is 6. Therefore, A is equals to 3. I hope you are all happy with that one. Let's determine B. We said 3A plus B is equals to the first term of the first difference, which is equals to 11. A is 3. We substitute A by 3 because we already got the value of A as 3. We substitute A here by 3 plus B must give us 11. 3 by 3 I think will give you 9 plus B is equals to 11. Therefore you transpose 9. You transpose 9 to the right. Then it will be 11 minus 9. Therefore B is equals to 2. Therefore B is equals to 2. Let's determine the value of C. Remember to find the value of C, we said A plus B plus C is equals to the first term of the pattern. The first term of the pattern, you remember, the first term of the pattern is 6. The first term of the pattern is 6. So we say A plus B plus C is equals to 6. Let's work it out then. A plus B plus C is equals to 6. What is the value of A? Substitute A is 3. Remember, A is 3. So we substitute A by 3 plus. What is the value of B? B is 2. We substitute B by 2. Then we need to determine the value of C. Therefore, 3 plus 2 gives you 5. Then you transpose. C will be equals to 1. I think the quadratic number pattern, remember, the quadratic number pattern is given as Tn is equals to an squared plus Bn plus C. Now, all we have to do is to substitute those values. Tn, what is the value of A? 3. 3n squared. What is the value of B? Our B here is 2. 2n. Our C here is 1. This is the nth term of the quadratic number pattern. The nth term of the quadratic number pattern is now Tn is equal to 3n squared plus 2n plus 1. I hope you're happy with the solution. And you have written it down. The nth term, Tn is equal to 3n squared plus 2n plus 1. Fine. Let's carry on and respond and answer the third question. Number 3. Hence 4.3. Hence determine the 50th term of the sequence. Remember we said hence means use the above solution to solve this one. Meaning the above solution you've got the nth term as 3n squared plus 2n plus 1. That is our solution, our nth term. So the question says the 50th term. T50, 3, you substitute n by 50. 50 squared plus 2 multiplied by 50 plus 1. Let's work it out. Let's simplify. 3. Then you say 50, you square it with the aid of a calculator. Work it out. I think it's 2,500 plus 2 multiplied by 50 gives you 100. Then you add 1. Let's multiply here. 3 by 0, 0. 3 by 0 is 0. 3 by 25 will give you 75, which is 7,500. Plus 100 plus 1. Therefore, the 50th term will then be equals to, if you add 7,500 plus 100 plus 1 to 7,601. That will be the 50th term of that sequence. The 50th term of that sequence is 7,601. Let's answer the last question then. The last question then states, which term of the pattern is equals to 162? Which term of the pattern is equals to 162? Sorry for that. Which term of the pattern is equals to 162? Remember, we are at 4.4. And the nth term we're talking about here is 3n squared plus 2n plus 1. So 162 would be our nth term here. 3n squared plus 2n plus 1. Now it's a quadratic equation. Let's write it in the standard form. Standard form, we've got 0 there. 3n squared plus 2n. It's 162. If you transpose it, it will be 1 minus 162, which will give you minus 161. Now you need to determine factors. It's a bit challenging. Remember, in case you cannot find the factors, always opt for a quadratic formula. And in the formula sheet, a quadratic formula is provided. But if you are able to determine the factors, let's go. Let's work it out. The factors, we've got 3n, and we also have n. So factors of 161, I think we can have positive 23 here and minus 7. Now we need to solve for n. If we solve for n here, it means 3n plus 23 is equals to 0, or n minus 7 is equals to 0. If you solve for n here, n will then be equals to minus 23 over 3. Or n here will be equals to 7. Those are the two values of n. But then the question states, which term of the pattern is equal to 162? N in this case indicates the position of a term in a sequence. So we can never have a position as minus 23 over 3. It doesn't make sense. So this one, you rule it out. It's not applicable. The only solution here is n is equals to 7. Meaning term number 7 is the one that is equals to 162. Thank you very much. I hope you've got the procedure that you need to follow when you solve quadratic number pattern. It's one of the key topics. It's going to be there on the 12th, this coming Friday. It's going to be there. So we need to make sure that really we understand the procedure very well, and we must be able to solve all these problems related to quadratic number pattern. Let me carry on with some more examples. And questions can be phrased in different forms. Check this one. Thank you. 6, 15, x, 45 is a quadratic number pattern. That is a quadratic number pattern. The question says determine the value of x. That is a quadratic number pattern. It's given. Now determine the value of x. What is key? You know that once it is a quadratic number pattern, the second difference is common. Once it is a quadratic number pattern, the second difference is common. Let's write down the sequence. We've got 6, we've got 15, we've got x. It is given that this is a quadratic, it's a quadratic number pattern. So determine the value of x. Let's determine the first difference. 15 minus 6. 15 minus 6, you've got 9. That is our first difference. X minus 15, our next term. 15 minus 6, 9. X minus 15, here it is. Here we've got 45. 45 minus x. That is our first difference. And remember, when you talk of a quadratic number pattern, the second difference is common. So this is the first difference. Let's determine the second difference. We don't have to hurry. We need to relax. Now we are going to determine the second difference. This is the term on its own, let's put it in brackets. This is a term on its own, let's put it in brackets. So to determine the second difference, we say this term, subtract this one. X minus 15. You need to subtract 9. Let's determine another second difference here. We've got 45 minus x here. We've got 45 minus x. So what do? We say 45 minus x. You subtract, what is it? Subtract this one, x minus 15. Let me note, this is the second difference. This is the second difference. So in a quadratic number pattern, the second difference is common. In a quadratic number pattern, the second difference is common. So let's equate them. It means this x minus 15 minus 9 is equals to x minus 15 minus 9 is equals to 45 minus x, let's remove the brackets, minus x plus 15. Now we just have to come and add the like terms. Thank you. We've got x minus 2x, transpose it to the left, to this x. Then it will be x plus 2x, which will give us 3x. Hope we are clear. Everyone is clear? We've got 3x. The question here says determine the value of x. On the right-hand side, because we have transposed this x and x, minus x minus 2x, and we've added them to this one, they've given us 3x. They've given us 3x. Now what are we left with? We are left with 45 plus 15. And 45 plus 15 gives us 60. Check minus 15 minus 9. Minus 15 minus 9 gives us minus 24. And that minus 24, you need to transpose it to the right. Then it becomes plus 24. Let's add the like terms. 3x. You add the 2. 84. Now, for us to determine the value of x, we divide by 3. If you divide by 3 here, you've got x. You divide by 3 here. 3 into 8 goes twice. 2 left. 2 put in 24. 3 into 24, it goes 6 times. It goes 6 times. It goes 6 times. As a result, the value of x should be 26. Let me check. You divide by 3 here, you've got x. You divide by 3 here, 3 by 6 gives you 18. 3 by 8, I think x will then be 28. I'm sorry for that. X is equals to 28. Take out your calculators and divide. 3x divided by 3, you've got x. 84 divided by 3 is equals to 28. So we have answered the question. The question here, x is equals to 28. You were only given a sequence, and then the question then states determine the value of x. I hope you still remember the question. Here is the question on top. 6, 15, x, 15 is a quadratic pattern. Determine the value of x. Interesting, eh? Thank you very much. Next one. I want you to solve this one. I'm going to give you 3 minutes for this one. Check number 6. Check number 6. For 3 minutes, you've got 1, 7, y, 31. It's a quadratic pattern. Determine the value of y. Thank you very much. I'm going to give you about 3 minutes to solve that one. Welcome. Let's check your work. Check your work against mine. Remember the question, 1, 7, y31 is a quadratic number pattern. Determine the value of y. So remember the key. Always number 6. Write the pattern down. 1, 7, y, 31. It's a quadratic number pattern. If it's a quadratic number pattern, the second difference is common. This is the first difference. 7 minus 1 gives us 6. This is the first difference. Y minus 7. These are the unlike terms. 31 minus y. That is the first difference. I hope it's clear. It is the first difference. So after determining the first difference, let's determine the second difference. The second difference here, you've got y minus 7, this term. You subtract 6. Another second difference, 31 minus y. That term, subtract y minus 7. So what is key about the second difference? Remember I said it's a given pattern, 1, 7, y, 31. This is the first difference. This is the second difference. This is the second difference. This is the second difference. And what is key about a quadratic number pattern is that the second difference is common. What is key? The second difference is common. Let's check. So it means y minus 7 minus 6 is equals to 31 minus y plus 7. If you remove the brackets here, 31 minus y plus 7. Let's add the like terms. This is a second difference. So second difference equal. This is y minus 13, which is equals to 31 and 7, I think it will give you 38 minus 2y. 38 minus 2y. Now let's group the like terms. Let's group the like terms. Transpose minus 2y to the left. Now it becomes plus 2y. You've got y plus 2y, y plus 2y. 38 minus 13. You've got 38 here. You've got 38. It's minus 13. Transpose it to the right. Plus 13. Let's add the like terms. Y plus y gives you 3y. 38 plus 13, 8 gives you 1, 5. Gives you 51. So all you have to do, you just have to divide by 3. And if you divide by 3 here, you've got y. You divide by 3 here, I think 51 divided by gives you 17. 51 divided by 3 gives you 17. That is the value of y. I hope you got it right. I hope you got it right. Let's carry on with different types of questions that we can come across in number patterns. Different type of questions that can be asked in number patterns. If you check number 7, I'm not going to do it with you. Number 7, consider the following linear pattern. Number 7, thank you very much. I hope it's clear now. It states number 7. Consider the following linear number pattern. Minus 4, x, minus 28, 40. It's a linear number pattern. Determine the value of x. Determine the nth term of the sequence. I'm not going to do this one with you. You can just jot it down. You can go and do it on your own when you arrive at home. But for now, because of time, I want to focus mainly on the quadratic number pattern, because this one is a linear pattern. 4x minus 28, 40. It's a linear pattern. It's an arithmetic sequence. So if it is an arithmetic sequence, the first difference is common. They've got the common difference. So you determine the difference between successive terms, then you've got the value of x. And then it's easy for you to determine the nth term of the sequence. So for this remaining 20 minutes or 25 minutes, I just want to focus mainly on the quadratic number pattern. Thank you. Quadratic number pattern. Maybe let's focus on number 9. Check number 9. Check number 9 there. Thank you very much. The nth term of the pattern is given by Tn is equals to minus 2 into n minus 5 all squared plus 80. Thank you. Is the nth term of the pattern. It is not specified which pattern this one is. Can you tell me which pattern it is by looking at it? Is it linear? Is it quadratic? What kind of a pattern is this one? Check. We've got n here, and it's all squared. So the moment you've got n and the square is going to be n squared. Therefore, it means this is a quadratic number pattern. You also know the parabola, the quadratic function can also be written in that form. So this is a quadratic number pattern. It was not stated. It is not stated that it is a quadratic number pattern. But by looking at the expression here, you as a learner, you should be able to identify that this must be a quadratic number pattern. Because if you square n minus 5 all squared, you'll have n squared. And the highest exponent, if it's 2, then it's a quadratic number pattern. It is not given that it's a quadratic number pattern. But by looking at the equation that is given, we are able to tell that it is a quadratic number pattern. Thank you very much. Thank you very much. Let's answer the question. Write down the first 3 terms of the sequence. Thank you. 9.1. Write down the first 3 terms of the sequence. What is given? We have the nth term, which is equals to minus 2, n minus 5, all squared, plus 18. So the first 3 terms of the sequence, let's determine the first one. It means you substitute n by 1. Wherever you see n, you write 1. It's minus 2, 1 minus 5 squared plus 18. Minus 2. 1 minus 5 all squared, I think it will give you negative 4. 1 minus 5, negative 4. Negative 4 is squared, it will be 16. Plus 18. Let's work it out nicely with the aid of calculators. Minus 2 multiplied by 16 will give you minus 32. It will be minus 32. Minus 32 plus 18. I think minus 32 plus 18 will then give you minus 14. That will be our first term. That will be our first term. I hope it's clear. You substitute n by 1. That's how we determine first term. Let's determine the second term. The second term, you write down the formula again. The second term. Write down the formula again. Tn minus 2 n minus 5 squared plus 18. Now, because you determine the second term, we substitute n by 2. Minus 2, 2 minus 5, plus 18. Let's simplify it further. Minus 2. 2 minus 5 gives you negative 3. But if you square it, it will be 9 plus 18. Let's determine the second term. 2 multiplied by negative 2. Negative 2 multiplied by 9 is negative 18. Negative 18 plus 18 gives us 0. It means our second term is 0. Our first term is negative 14. The question states, write down the first 3 terms of the pattern. Write down the first 3 terms of the sequence. So we've already determined the first 2. In the very same way, let's determine the third term. In the very same way, let's determine the third term. Let's write down the formula. Tn is equals to minus 2 into n minus 5 all squared plus 18. Now, what do? We substitute n by 3. 3 minus 2 into 3 minus 5 squared plus 18. What we did was to substitute. What we did was to substitute the value of n by 3. Let's simplify it. It's minus 2. 3 minus 5 gives you negative 2. When you square it, it's 4. Plus 18. Therefore, our third term is equals to, minus 2 multiplied by 4 is going to be negative 8. Negative 8 plus 18 will then give you positive 10. So, when answering the question, the first 3 terms are minus 14 is the first term, 0 is the second term, and third term is equals to 10. Those are the first 3 terms of the sequence. The first term is minus 14, the second term is 0, the third term is 10. Those are the first 3 terms of the sequence. The question stated, if you remember the question very well, the question stated, write down the first 3 terms of the sequence. Write down the first 3 terms of the sequence. So we said those first 3 terms is minus 14, it's 0, it's 10. That is 9.1. How we answer 9.1. I hope you're happy with it. I hope you are happy with it. Let's check 9.2. What is the second difference of this quadratic number pattern? What is the second difference of this quadratic number pattern? So all we have to do is to determine the first difference, after determining the first difference, and then determine the second difference. Check. This is the first thing. 0 minus negative 14. You've got 14. 10 minus 0 is 10. This is the first difference. First difference. The question states, what is the second difference of this quadratic number pattern. It wasn't stated here in the quadratic pattern, but because it was squared, we concluded that it is a quadratic pattern. And finally, even this question states what is the second difference of this quadratic number pattern. So this is the first difference. If it's the first difference, quadratic number pattern, the second difference, there must be second difference. And second difference is common. Let's determine the second difference. 10 minus 14 is equals to negative 4. Therefore, second difference is equals to negative 4. That's what the question wanted. What is the second difference of this quadratic pattern? So the second difference here is negative 4. I hope you are happy with this. Time is against us. We only left about 10 minutes, 15 minutes or so. So can I humbly request that I give you an exercise? Do your best. The questions are phrased differently. We may not be able to solve all the problems, but now for the remaining few minutes, I will be focusing mainly on the approach. Check the next question. Question number 10. Consider the pattern. Minus 4, 15, minus 32, minus 55. If the pattern continues in this manner, show that it is a quadratic pattern. The question states, show that it is a quadratic pattern. And then 10.2, find the general term of the pattern. But it's clear, consider the following pattern. Minus 4, minus 15, minus 32, minus 55. If the pattern continues in this manner, show that it is a quadratic pattern. And then the 10.2, find the general term of the sequence. I think I can give you, if you can only answer 10.1. I'm interested only in 10.1 because 10.2, I think we have done lots and lots of problems similar to that one. You can just note it down and you can do it during your spare time when you practice. For now, just 10.1. I'm going to give you 2 minutes for 10.1, please. Welcome. Consider the following pattern. Minus 4, minus 32, minus 55. Show that it's a quadratic number pattern. 10.1. Let's write down the sequence. Let's write down the pattern. Minus 4, minus 15, minus 32, minus 55. Let's determine the first difference. The question states, show that it is a quadratic number pattern. If it is a quadratic number pattern, the second difference must be common. Negative 15, you subtract negative 4. Negative 15, you subtract negative 4. I think if you subtract, you've got negative 11. Negative 32. Negative 32, you subtract negative 50. I think if you subtract, you've got negative 70. Negative 55. Negative 55, subtract negative 32. Negative 55, subtract negative 32. I think if you subtract properly, they'll end up with negative 23. That is the first difference. Let's determine the second difference. Negative 17, subtract negative 11. Negative 17, subtract negative 11. Then you end up with negative 6. Let's check. Negative 23, subtract negative 17. Negative 23, subtract negative 17. The answer is still negative 6. Thank you. This is the sequence of the pattern that was given to us. This is the first difference. Look at the second difference. The second difference is common. So if the second difference is common, conclude by saying this is a quadratic pattern. The question says, show that it is a quadratic pattern. Then you conclude this is a quadratic pattern because second difference is common. That's why we say it is the quadratic number pattern, because the second difference, check, this is the second difference, it's negative 6. This is the second difference, it's negative 6. So the second difference is common. The second difference is constant. Therefore, this becomes a quadratic number pattern. We can even solve the last one. The last one states, find the general term of the pattern. Find the general term of the pattern. I think we must be familiar with determining the general term of the pattern. We have done lots of exercises of this type. Remember, we said the general term is Tn an squared plus Bn plus C. So it's easy to determine the nth term of the pattern, because to determine the nth term, remember A, so 2A is equals to common difference. And our common difference in this case is -6. So divide both sides by 2. Therefore, A is equals to -3. I hope it's clear, that one. A is equals to -3. How do we determine the value of B? To determine the value of B, we said 3A plus B. 3A plus B is equals to the first term of the first difference. Let's check the first term of the first difference. The first term of the first difference here, check. This is the second difference. The first term is -11. So 3A plus B is equals to -11. We already know the value of A is -3. Substitute A by -3 plus B is equals to -11. You multiply that two, they give you -9. -9 plus B is equals to -11. Then you transpose B 9 to the right. If you transpose -9 to the right, then you'll be left -11 plus 9, which will give you -2. You've got the value of B. You've got the value of A, you've got the value of B. So to determine the value of C, remember we say A plus B, A plus B, I'm sorry for that. A plus B plus C must give us -4, which is the first term. Our first term was -4. So you've got the value of A is -3, or B is -2, plus C is equals to -4. So you transpose -3 and -2 to give you -5. -5, transpose it to the right. So -4 plus 5, which will give you 1. What does that mean? It means the nth term, our nth term in this case, Tn, an squared. It's going to be -3n squared -3n squared minus 2n plus 1. That will be our general term, -3n squared minus 2n plus 1. That is how we'll answer that one. Let me round it off. I think we are only left with about 5 minutes. The key behind solving quadratic equation, the key behind solving quadratic equation is to remember that every solution, the second difference is common. I think we have done lots and lots of exercises, and in almost every exercise, for us to solve a quadratic number pattern, we must know that the second difference is common. That is the key in solving all the quadratic number patterns. If I were to take you through this one, because of time I won't be able to do it, I can just show you. Dots are arranged to form a sequence of a pattern as shown below. Look at the dots. Question is mainly focusing on the dots. Check dots. How many dots do we have here? How many dots? See, you only have one dot. In pattern number 1, you only have one dot. Let's go to pattern number 2. How many dots? Can count them. 1, 2, 3, 4, 5. You've got 5 dots. Pattern number 3, how many dots? Remember, the inner one gives us 5 terms. So you just have to calculate the outer ones. 1, 2, 3, 4, 5, 6, 7, 8. It will be 8 plus 5 will then give us 13 dots. So even here, if you check 1, 2, 3, the inner ones, they give you 13 dots. They give you 13 dots. So you just have to count the outside one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then it will be 13 plus 12 will then give you 25 dots. Dots are arranged to form a sequence, of pattern. So let's check the first one. Write down the number of dots in the fifth sequence. For you to be able to write down the number of dots in the fifth sequence, just check the pattern. Check the pattern. What kind of a pattern is that one? That is key. What kind of a pattern is that one? You had 1, 5, 13, 25. What kind of a pattern is that one? Check the first difference, okay? Remember I said 1, 5, 13, 25. We don't know what type of a pattern is this one. Let's check the first difference. 5 minus 1 is 4. 13 minus 5 gives us 8. 25 minus 13. 25 minus 13 gives us 12. So you can see already the first difference is linear. Once the first difference gives you linear, it means the second difference must be constant. Check. 8 minus 4 is 4. 12 minus 8 is 4. The second difference is common. It's a quadratic number pattern. It is a quadratic number pattern. So to answer the questions, write down the number of dots in pattern 5. This is pattern 1, pattern 2, pattern 3, pattern 4. In pattern 5, what do? It means it's 4, 8, 12. The next term here will then be 16. So 25 plus 16 will then give you 41. So it means in answering here, 11.1, write down the number of dots in pattern 5. There will be 41 dots. I'm just saying questions can be phrased differently. But you need to be able to establish first the type of a pattern we're talking about. Once you have established the pattern, then all other questions I think they can be solved easily. Let me take this opportunity to wish you well. I know on this coming Friday, you'll be sitting for mathematics paper 1 for 3 hours, grade 12s, 3 hours. I wish you well. Please keep on practicing. I hope today, in as far as number patterns is concerned, you have learned something. And the key behind quadratic number patterns is that second difference is common. Once you can understand that, once you can know that, you'll be able to solve any problem related to quadratic number pattern. Good luck on Friday. Prepare well. Take time to write the question paper. Remember, a formula sheet will be provided. A formula sheet will contain all those formulas that will be used in solving the questions in the question paper. If you can just relax and take your time, I'm confident that you will make it. But you need to practice a lot, because there is a lot of content in mathematics, especially in paper 1. There are lots and lots of topics, including all the topics that you did in grade 10 and 11. I hope today's lessons has added value to you. And I believe, in a way, you will be inspired and you will be able to do well in these coming examinations. I wish you well. God bless. Thank you.